welcome once again in the video lecture of Communication Engineering KEC 401. So, in the last video lecture we have discussed the various aspects of amplitude modulation. Today we are going to discuss about the generation and detection of amplitude modulated waveform. Here we have two important methods with the help of which we can generate AM waveform, that is square law modulator, and the second one is switching modulator. So, let us start with the discussion of generation of AM waveform with the help of square law modulator. What is square law modulator? It is a device having three important components, that is adder, a non-linear device or a square law device, and a bandpass filter. What is the main idea behind the generation of AM wave with the help of this square law modulator or with the help of non-linear device? That is, with the help of this particular method we can generate a amplitude modulated waveform. First we will have our message signal, that is a baseband signal, low frequency signal. Then we have a carrier signal that we can generate with the help of a local oscillator. The adder will provide the summation of message signal and this carrier signal AC cos 2 pi FCT. So, at the output of adder, what we will get? We will get the summation of message signal and the carrier signal, that is MT plus AC cos 2 pi FCT. After this input will be passed, or this summation of the message signal and the carrier signal will be passed from a non-linear device or a square law device. What is a non-linear device? We know that non-linear device is having non-linear properties between input and output signal. So, any device which is having non-linear relationship between input and output we can use here, like diode or transistor. So, what is the output or the input output relationship of a non-linear device? It is like this equation, that is A1 V1 plus A2 V1 square. Here we have considered only two terms, the first two terms up to second order. We can also expand this summation up to some higher order terms also, like A3 V1 cube, A4 V1 raised to the power 4, and so on. But if the value of the input signal is a smaller value, then we can neglect the higher order term. So, here we have mentioned, or here we have expressed the output of this non-linear device up to second term only. Okay. So, after passing the output of this non-linear device, after getting the output from this non-linear device, the next step is to pass this output from a bandpass filter. What is a filter? Filter is a frequency selective network that passes desired range of frequencies while reject others, that passes signals of desired range of frequencies and reject other signals. So, we can select bandpass filter in such a manner, so at the output of this we will get the signal of desired frequency range and we can neglect the rest of the signal. The output of this bandpass filter then will become amplitude modulated waveform. So, let us check the mathematical analysis of the output that we are getting from this square law modulator. So, after adding the message signal and the carrier signal with the help of adder, what we will get? We will get MT plus AC cos omega CT. When we will pass the same through a non-linear device, that is a square law device which is having the properties like this, after putting the value of V1, that is the summation of M1 MT and AC cos 2 pi FCT, we will get this mathematical expression. Expanding this expression, what we will get? We will get A1 MT plus AC cos 2 pi FCT plus A2 M square T plus A square C cos 2 pi FCT whole square plus 2 times of MT AC cos 2 pi FCT. So, the output of square law device will become this equation. In this equation, the terms mentioned with the red, that is the first one the third one and the fourth one. We are not interested in these three terms. So what we can do, we can place or we can select a band pass filter with cutoff frequencies that will reject the signal, that is the first term, this third term and this fourth term, while passing the remaining terms. So by the proper selection of band pass filter cutoff frequency range, we can eliminate these three non-desired terms. So the output of band pass filter in that case will become the summation of the remaining two terms, that is A1 AC cos 2 pi FCT plus twice of A2 MT AC cos 2 pi FCT. Rearranging this expression, we will get the final output of the band pass filter as A1 AC 1 plus twice of A2 by A1 MT cos 2 pi FCT, that is the amplitude modulated waveform. It will compare the output of this band pass filter with the standard equation of AM wave that we have obtained in the last video lecture also, that is S of AMT equals to AC plus AC1 plus KAMT cos 2 pi FCT, where Ka is the amplitude sensitivity parameter. So we will compare the output of this band pass filter with the standard equation of AM. We will get that the product of A1 AC is equivalent to AC and Ka is equivalent to twice of A2 upon A1. So in this way we will get the amplitude modulated waveform with the help of a square low modulator device. The next thing is the detection or the demodulation of the AM wave. The detection or the demodulation process is used to be performed at the receiver. What is demodulation or detection? It is the process of recovering the original masses back from the modulated waveform. The circuit with the help of which we used to perform this demodulation or the detection of the masses signal is known as demodulator. Here we have two important categories of demodulator, that is square low demodulator and the envelope detector. So we are going to discuss the detection of AM wave with the help of envelope detector in detail. What is envelope detector? It is a simple and highly effective method with the help of which we can perform the demodulation of AM signal. This envelope detector consists of a diode and a low pass filter, which is nothing a combination of a capacitor and parallel combination of a capacitor and resistor. Here in this circuit of envelope detector, this diode is the main detecting element. So that is why sometimes this envelope detector is also called as diode detector. What is the logic behind the detection of masses signal with the help of this envelope detector method is, at the input of this circuit we used to apply our input AM wave, that is amplitude modulated wave. This amplitude modulated wave, this portion, that is the envelope, the outer portion of this AM wave, we can mention as AC plus MT. The outer portion of this AM wave is nothing, it is the summation of AC plus MT. What is AC plus MT? As we have discussed in the last lecture also, AC plus MT is used to be called as the envelope of the AM waveform. So the shape of this envelope of amplitude modulated waveform is very much similar to the masses signal. What is the logic behind this amplitude modulation? The amplitude of carrier signal will vary according to the masses signal. So here that is the maximum amplitude of the carrier signal. The amplitude of carrier signal is varying according to the masses signal. So this envelope AC plus MT, the shape of this envelope is very much similar to the shape of masses signal. So, if somehow we will be able to detect this shape or this envelope of this AM wave, then we will also be able to detect the masses signal. So, what happens in this envelope detector? During the positive half cycle of the input waveform, that is amplitude modulated waveform, the diode will become forward biased and will act like a short circuit. When we have the positive half cycle of this AM waveform, then this diode will become forward biased and it will act like a short circuit. When this diode will act like a short circuit, then this capacitor will get charged up to the value of applied input voltage, that is V in. In the next, when the input signal falls below the output voltage, the diode become reverse biased and the capacitor then start discharging gradually through the load resistance, that is R. What happens here? During the positive half cycle, when the input is positive, then diode will become forward biased and the capacitor will start charging towards the input voltage. So, what we will get? We will get the, so this will be the charging of the capacitor. When the voltage, input voltage is lesser than the voltage across the capacitor, then the diode will become reverse biased and the capacitor will start discharging. This is the discharging of the capacitor. The discharging of the capacitor should be gradual and the charging of the capacitor should be quick. So, in this way the capacitor will keep on charging and discharging depending on the value of input voltage. So, here we have the charging and discharging of the capacitor. So, what this shape is giving to us, this charging and discharging of the capacitor is giving us the shape of the envelope of amplitude modulated waveform, that is the envelope of the AM waveform, that is similar to the shape of masses signal. The discharging process continues until the next positive half cycle of the input signal. When the value of AM wave is greater than the voltage across the capacitor, the diode conducts again and the process will be repeated and we will get the shape of the envelope at the output of envelope detector. Here some points to be noted, that the time constant of the low pass filter, that is RC, should be selected in such a manner that it will be able to follow the variations in the envelope of the modulated signal. What is the meaning of this? If we select the value of the component RC too large, then the discharge of the capacitor is too slow, then the output will not follow the envelope like this. If RC is selected too large, then the discharging of the capacitor, that is this one, is too slow and it will not able to capture or follow the envelope properly. Secondly, if we select the value of the RC too small, then again the output of the filter falls very rapidly and after each peak, and it will not be able to follow the envelope. Like here, if we select the value of RC too small, then we will get like output of the envelope detector, this one. So, what should be the condition for selecting the value of RC component? For good performance of the time constant, for good performance, the time constant RC of the envelope detector should satisfy a condition, that is, it should lie between 1 upon Fc to 1 upon Fm, where Fc is the frequency of carrier signal and Fm is the maximum frequency of the modulating signal or the maximum frequency of the masses signal. So when we select this RC constant lying in this range, then this envelope detector will be able to follow the variations in the envelope of the modulated signal. Here one more point to be noted, that with the help of this envelope detector we can detect signals having modulation index less than equals to 1. The envelope detector can extract only the positive portion of the amplitude modulated waveform. When we have this condition where modulation index is less than equals to 1, then the entire masses will be contained within the amplitude modulated waveform, and this envelope detector will be capable of detecting the shape of the masses signal efficiently. If we select the condition where modulation index is greater than 1, then we used to get distortion in the output waveform. So we generally apply this method of detection of AM wave where we have modulation index less than equals to 1. So what are the advantages of AM modulation? It is very easy to implement and the detection is also easier, as with the help of very few components like diode, resistor and capacitor, we can perform the detection of AM waveform. AM wave can travel longer distances. AM receivers are cost efficient, as the cost of diode, capacitor and resistor is quite low. What are the disadvantages associated with AM modulation? The very first disadvantage of AM modulation is that the power is wasted in transmitted signal. What we used to do, we used to transmit carrier and the two sidebands, that is upper sideband and lower sideband, in AM modulation. We have seen in the last video lecture that carrier does not carry any useful information, and its transmission, the transmission of carrier required 2/3 of the total power, that is wastage for us. AM requires larger bandwidth. The transmission bandwidth required for amplitude modulation is twice the value of maximum frequency component present in the masses signal. AM gets easily affected due to noise, as the main effect of noise is on the amplitude of the signal, any signal, and in amplitude modulation our information is stored in the amplitude variation of the carrier signal. So it is easily gets affected due to noise. The major application of amplitude modulation are in radio broadcasting and in TV broadcasting. So this is about the generation, detection, advantages, disadvantages and application of double sideband full carrier amplitude modulation. The next we are going to discuss about the double sideband suppressed carrier modulation. What is DSB-SC modulation? So in the last type of modulation, that is a type of amplitude modulation or conventional amplitude modulation, we have seen that in conventional amplitude modulation we have to transmit carrier along with upper sideband and lower sideband. The carrier does not contain any useful information about the masses signal. So the transmission of the carrier wave is a wastage of power, which makes the transmission inefficient. So what we can do, we can overcome this limitation by suppressing the carrier component from the modulated wave. That will result in double side suppressed carrier, that is also called as DSB-SC modulation. Okay. So thus by suppressing the carrier we obtain a modulated wave that is proportional to the product of carrier wave and the masses signal. So what is DSB-SC modulation? DSB-SC modulation is the second category of conventional amplitude modulation, where we suppress the carrier and now we do not have any need to transmit the carrier along with the sidebands to improve the efficiency and to save the power. Let us discuss how we can generate this DSB-SC signal. The DSB-SC signal can be generated simply by mixing the massive signal with the carrier signal. This mixing of massive signal and carrier signal can be performed with the help of a product modulator. It can be done with the help of balanced modulator also. So, what this mixer will do, it will provide us the multiplication or the product of massive signal and carrier signal, that is the DSB-SC output. Let us check how we will get the DSB-SC output. What is the standard expression for DSB-SC waveform? So, here we are considering for single tone modulation. What is single tone modulation? Single tone modulation is where we define massive signal MT as AM cos omega MT, where omega m is 2 pi FM, that is the frequency of the massive signal. So, what is single tone modulation? Where we consider only one frequency component in the massive signal. So, considering massive signal as AM cos omega MT and the carrier signal as AC cos 2 pi FCT. When we will mix both of them, what we will get? The product of MT into CT. So, the output of this mixer is what? The product of CT, that is carrier signal, and MT, that is massive signal. So, CT is AC cos omega CT, MT is AM cos omega MT. Rearranging this equation, we will get AM into AC cos omega CT cos omega MT. With the help of trigonometric relationship between that is cos A cos B, we can rewrite this equation as AM into AC cos of omega C plus omega MT plus cos of omega C minus omega MT divided by 2. Again, rearranging this equation, we will get AM AC by 2 cos omega C plus omega MT plus AM AC by 2 cos omega C minus omega MT, which is the standard expression for our DSB-SC signal. Here we can observe that in the standard expression of this DSB-SC signal, we have only two terms. The first term, where we are getting the summation of carrier frequency and massive signal frequency, that represents upper sideband, and the second one where we are having the difference of carrier frequency and massive signal frequency, that is omega C minus omega M, that is the indication of lower sideband. In this expression, we are not having the term, that is AC cos 2 pi FCT, that we were getting in the last case, that is conventional amplitude modulation. So, here in DSB-SC signal, we have only the two sidebands, that is upper sideband and lower sideband. So, in the transmission of DSB-SC signal, we have suppressed the carrier, and now there is no need to transmit the carrier along with side bands. It will improve the efficiency and will save the power for transmitting this amplitude modulated waveform. The detection of this DSB-SC signal can be done in two ways. What are the two ways of performing the demodulation of DSB-SC signal? It can be done with the help of a coherent detector or a synchronous detector. It can be done with a non-coherent detector, or we can say a Costas loop detector. What is coherent detection or synchronous detection? In coherent detection, we have to use the carrier signal at the receiver having same phase and frequency that we were originally using at the transmitter. So in coherent detector, we need a carrier signal having same phase and frequency that we were using at the transmitter. In non-coherent detection, it is quite simpler, but here we do not have any need of carrier signal. So in case of coherent detection or synchronous detection, we used to get the demodulation or the detection of the amplitude modulated waveform in a more accurate manner, while this method is easier to implement. The coherent detection and the synchronous detection of DSB-SC signal we will discuss in next video lecture. In this video lecture, we have discussed about the generation and the detection of conventional amplitude modulated waveform. The generation we have seen with the help of square low modulator, that is a non-linear device. The detection of amplitude modulated waveform we have seen with the help of envelope detector. Then we have seen the advantages, disadvantages and the application of AM waveform. Then we have seen the main disadvantage of AM waveform is the wastage of power in transmitting carrier along with the sidebands. So in DSB-SC, what we have done, we have suppressed the carrier and need to transmit it with the sidebands. Then we have seen the generation of DSB-SC signal with the help of a mixture, that is simply provide us the DSB-SC signal by multiplying the masses signal along with the carrier signal. This mixing we can done or we can perform with the help of a predict modulator or a balanced modulator. In the next video lecture, we will discuss the detection of DSB-SC signal with the help of coherent detector and synchronous detector, and will also see what improvement in the efficiency we will get if we are sending or if we are performing DSB-SC modulation. Thank you everyone.